Good morning, ma'am. I am Harshit from 2nd ECE department. Today's my topic is Smith chart, impedance matching and applications. My roll number is 234g1a0443. Smith chart, impedance matching and matching applications. This presentation introduces the Smith chart. It explores its significance in impedance matching. We will briefly touch on its historical context and evolution. We will highlight the importance of impedance matching in RF applications. Understanding the Smith chart. In Smith chart there are the types resistance and reactance, SWR circuits, admittance overlay. In resistance and reactance, understand the Smith chart's components. Resistance and reactance circles are key. And next, SWR circles. In SWR circles, learn about constant SWR circuits. They help visualize impedance matching and admittance overlay. Use the admittance cohort chart overlay. This aids in complex calculations. Read and interrupt impedance values. Locate points with illustrative examples. Impedance matching basics. Optimal power transformer, reflection coefficient, signal reflections. And then first one we can discuss about the optimal power transfer. In optimal power transfer, impedance matching ensures optimal power transfer. In reflection coefficient, understand the reflection coefficient L and VSWR and loss these signal reflections. Mismatch leads to signal reflections and power loss. Introduce complex conjugate matching to minimize power loss. And we can minimize the power loss, we can introduce the complex conjugates. Matching with lumped elements. And there are two types of ohm sources. They are 50 ohm source and 75 ohm source. And then first we can discuss about the 50 ohm source. Match a 50 ohm source to 20 plus J30 ohms. Use a series capacitor and shunt inductor. In 75 ohm source, match a 75 ohm source to 10 to J20 ohms. Use a series inductor and shunt capacitor. Use the Smith chart. Design matching networks with inductors and capacitors. Follow a step-by-step procedure for selecting elements and elements. Matching with transmission line and line stubs. In that there are two, single line stub matching and double line stub matching. In single line stub matching, match 100 plus J50 ohms to a 50 ohm line. Calculate stub length and distance. Double stub matching. In double stub matching, match 25 to J25 ohms to a 75 ohm line. Calculate stub length and spacing. Using the Smith chart, design single and double stub matching networks, detailed networks, and detailed stub placement and length calculation. In the real-world applications of RF amplifiers. In real-world applications, there are three types. They are input matching, output matching, and maximize power gain. In that, firstly, we can discuss about the input matching. Input matching in design input matching networks for RF amplifiers. In that RF amplifiers, they then design input matching will be networks of the RF amplifiers. In that output matching, design output matching networks for RF amplifiers and design output of output matching for RF amplifiers. In the last one is maximum power gain or maximize power gain. In maximize power gain in RF amplifiers, match a transistor amplifier input impedance to 15 plus J10 ohms to a 50 ohm source. Consider stability and bandwidth. We can consider these real world applications for the stability and bandwidth. Real world applications. Antenna design. Effect radiation or efficient radiation. Feed line Impedance, antenna performance, and VSWR impact. Optimize antenna impedance for radiation. Match antenna impedance to feedline line impedance. Antenna performance. Consider performance gain radiation pattern. VSWR impact. See the impact on VSWR. Match a monopole antenna. Impedance is 32 J20 ohms to a 50 ohm coaxial cable. Conclusion. Key applications. The Smith chart is a key in impedance matching. Future trends. Consider future advancements and techniques. Future learning. Explore resources for learning. Recap applications. Explore books, software and tutorials. Thank you, ma'am.